Wayne, thanks for sitting down with me today. I appreciate it very much. As a plant breeder focused on grasses and turf, forage and turf rather, I want to break this into a couple of stages, because obviously you've got a broad scope of work to talk about here today. So first, let's look at forages. What do you see for trends there, and what do those trends mean to you as a plant breeder?
You know, I've been out of forages for about 15 years. I stopped working with forages in 2003, but I've been working with clover, which is a forage, a legume, and so I've watched it from that point, but from a grass point of view, I've been developing forages since 2003, but we hired Bill Anderson to take over that program. And, you know, forages have very little political support. Until they get some political support, maybe from animal science. In the years that Dr. Burton and I were doing forage breeding at Tifton, we had active forage programs. We worked very closely with animal scientists. We had animal science data because we had animal science data with the forage data. They were very popular. We don't have that type of information today. And so it's harder, the forage research is more difficult. It's wilting because of lack of support. Until there's an advocate, a strong advocate for forage research, it's going to wilt. Right. There's some things that I think that in forages that could make a difference. In forage and turf, drought tolerance, water use efficiency. In turf, it's more high profile, and you got to do it because turf is high profile. In forages, you have to do it because you can't afford to irrigate forage. And so you're going to have forages that survive. In order for them to be productive, you need drought tolerance. Not so much for public visibility, but for forage survival and production, you need drought tolerance. And I think another thing, I've thought about this a little bit the last couple of days, and I think nitrogen efficiency is a key. It's gotten very expensive. All costs have increased. Cattle prices, all these other commodity prices have not increased at the same rate that input costs it takes to produce it. And so I think nitrogen efficiency, those two, I would think nitrogen efficiency, both in turf, in turf mainly for an environmental point of view. Right. But in forages for efficiency of production.
So if you've been able to bring together because my next question it was going to be exactly that. With turf, how does it differ? But I think you've been able to bring those two together, because turf is obviously your most current spectrum of work, and which is where you're playing now.
Yeah.
What does that mean? So when you look at those two pieces, A, is there other things that are key with turf? And B, how does that affect what you have to do as a plant breeder?
Yeah. Well, in addition to, say, nitrogen use efficiency, I think phosphorus is always a problem to deal with. So phosphorus use, most soils are so darn full of phosphorus anyway. A lot of them are phosphorus mines, and we keep on putting phosphorus. But nitrogen leaches so fast, so that's very important. But yeah, I mean, what it means in the turf business is that our breeding programs have to use screening techniques to screen for that. For instance, we did a test 10 years ago. We had about 200 selections out of 27,000 that we had, and we put recommended nitrogen, and we put 50% of nitrogen. Most of them showed a reduced nitrogen. There were 2 or 3 that you couldn't tell the difference between recommended nitrogen and 50% nitrogen. So that tells me there's something there. We haven't released a cultivar in that area, but I think just released a turf, Tiff Tough, that uses 38% less water than Tiff Way 419, the most popular athletic field landscape grass around the world. Triploid, improved fine texture. We just released Tiff Tough, which uses 38% less water. That's key. That's the beginning. We're going to need to do better. We need to do better.
You have, to say you've been successful would be a bit of an understatement. According to the university, your patents have generated $7 million in gross license revenue, plus another $3 million from plants protected by PVP certificates. So part of that tells me successful, but I think what tells me more successful is when when I walk around at NAPB here, your name comes up as the person that I should talk to if I want to get excited about plant breeding.
Yeah.
Your passion comes across.
Yeah.
So what makes you unique in this environment of scientists? Because, I mean, let's be honest, between you, me, and the fence post, scientists aren't necessarily known for their over-exuberant.
Oh, yeah.
Right? So,
Oh, yeah.
so what's unique? You tell me what's unique.
Well, you know, it kind of, success breeds success, enthusiasm breeds enthusiasm. We're successful, and we're successful because we have a good, we have a plan, and we work the plan. We have a great plan that we have, and we work very efficiently. We don't waste time. And so, you know, if you waste 15 minutes in the morning and 15 minutes in the afternoon, 30 minutes a day, you know what that is in a year? That's over 16 working day, 8-hour working days in a year. That's over 3 weeks. Just if you don't waste 30 minutes in a day. So we have 16 working days, 8-hour working days advantage over a lot of people that are not as efficient. We work hard. And we test thoroughly. Our grasses, we work at mainly perennials. We have one pearl millet, the summer annuals, they're an annual crop, but most of ours are perennial. And grown, say, 37, 38 degrees around the world. That's 80% of the earth. But before we release one, we tested under a lot of different climates, management regimes. And so when ours go out, they look good around the world. And that breeds success. And even then, if we didn't, another key, I think, to our program is that we work with the consumer, the propagators, the growers that produce the seed for the customer. We work with them in the development process. So they are part of the team that's coming along. And when we come out, they're ready to go. They're not gearing up how we're going to produce it, what we're going to do, when we're going to do it. They're ready to go.